This is an overview of the SCALE system. SCALE stands for Self-Constructing Auxiliary Living Environment. Natural disasters and armed conflicts have created scenarios where millions of people have been forced out of their homes and into refugee camps that in no way reflect conditions that a human being should live in. In order to create a refugee camp fit for human needs, there are three essentials: suitable land, proper materials, and qualified labor. Governments and NGOs can provide land and materials, but there is always a lack of labor. The objective of this system is to create a full-scale, self-assembling emergency housing solution to provide semi-permanent living spaces for natural disaster victims or war refugees, or, as the project dictates right now, a prefabricated, pre-assembled, collapsing and expanding solid panel modular structure that can be easily transported in shipping containers and quickly deployed either by an untrained person or a self-driven robot. The system consists of two main parts: an emergency housing module and a construction robot. The housing module is a tensional integrity structure based on an origami figure that collapses and expands with ease. To illustrate key elements of the housing module, the tracks for the forklift double as connectors for interlocking the housing units to generate modular constructions. The structural core, located at the symmetry axis of the front panel, is fitted with an internal thread that guides the deployment of the entire structure. When the module is expanded, you open access to doors on each of the four walls, windows on the two side panels, and skylights that provide natural light for the inhabitants. The robot comes with three main mechanisms: a drivetrain to move around the work area, a forklift in the front that allows for lifting and setting the housing modules, and a sliding drill turret that deploys the module by drilling and sliding forward at the same pace to maintain balance. The distinct colors in the front and back enable the navigation software to determine the robot's orientation. There are multiple elements necessary for the system's deployment sequence: a shipping container that holds up to 45 housing modules, the construction robot whose work area is located directly in front of the shipping container doors, a high-resolution camera set on a telescopic pole mounted on the shipping container to provide an overview of the work area, and a computer that processes the information from the camera and provides direction and commands to the robot. The assembly sequence begins with the robot locating and gripping a housing module from the shipping container. The robot lifts the module and moves out into the work area. The robot, receiving instructions from the computer, is guided to the location where the module is to be deployed. Once the destination is reached, the drill is activated and the module is expanded. The robot lowers and releases the expanded module and returns to the container to repeat the sequence until the container is empty.